Good morning, Doctor. So today we want to interview Doctor about our research today. The title is The Study on Payload Concept for Small Satellites in the Scope of the National Interest of Malaysia.
Okay.
So the first question is, can you share your educational and professional background related to satellite technology program?
My background is it?
Mm-hmm.
Basically, I'm specialized in spacecraft systems. Well, specifically on attitude control, attitude elimination, power systems, thermal systems. More into spacecraft subsystems.
Okay. The next question is, what is your motivation venturing in the space program?
Because it's the mother of all sciences, rocket science.
So interest.
So when you can do probably space science, you should be able to actually do most of other things, almost. It's a very application field, and you've been exposed to not only one particular field but many other fields: mechanical, electrical, computer science, mathematics, of course. So many other fields. You need all those knowledge basically to support space engineering. That's the reason when you can function in space engineering, you should be able to function in other fields easily. Rocket science, remember?
Yeah.
So rocket science is very complex.
Yeah. The third question: as a researcher, what is your vision regarding satellite technology research and development R&D in the universities and the country as whole?
Smaller than small.
Smaller than small.
Yeah. Building smaller satellites. That means many synergisms, doing the same work but in a very efficient manner with the smaller payloads and smaller platforms. That is the future, if you ask me.
For next question, how would you describe the landscape of Malaysia satellite technology R&D program until now?
Frankly speaking, quite slow. Why it is quite slow is because we don't have any formal continuous satellite programs in the country. We had Razak Tiumsat, small satellite. Then we had Razak Sat 1, which is failed. Then after that there was a vacuum. So the research and development of satellite technologies in the country is a bit slow in that sense. But nevertheless, I think here in UPM, I think we are doing quite well in that sense. Very specific topic, very deep research in satellite field. I think we can compete globally in that sense. But if you want to ask me, well, come let's build on satellites, you need to provide the budget. So that's it. Everything is expensive in space business, and budget is the main concern. So when you have the money, when you have the people, then you should be able to do it. But I think we started quite well, but at the moment I think it's quite slow. I think there should be a continuous program, even the small satellite programs, not one but multiple programs, so that we can compete and maybe do a demonstration mission, different kind of technologies, maybe different kind of partnerships that need to be done. That is quite lacking in the country. But I don't blame much, because I think Malaysia per se, it is not a space nation. So there are a lot of other priorities in the country, but nevertheless, space technology or rather space field is very important and strategic for any country, because it is a derivative technologies, and most of the technologies that we see will be actually supporting national security. So like it or not, if you want to have a good secured country, I think space will become very relevant. So that's what is very important, that we keep on investing in space. If we can keep on investing in military, I would say assets, that means we should be able to also invest on space assets, because that is for the security of the country. But I don't foresee, or rather I would not recommend Malaysia to participate in interplanetary missions.
Why is that?
Because I think too much of investment, too much of technology. I think that money we should be able to use it for some other purposes in the country. But as far as Earth-oriented missions, especially maybe Earth observations for national security, I think it is a must. It can be actually also considered as one of those components that the country needs. And we have, if you look at our waters, huge area. We have the East Malaysia, we have the West Malaysia, and we have a lot of waters basically to take care, and a lot of boundaries. And I think this kind of technologies should be able to help us do things efficiently.
Okay, thank you, Doctor. So we're going to ask you more specific question. You don't remember? Okay, so the first question: in your opinion, based on empirical data you have gathered, how can satellite help developing Malaysia?
How can
satellite help Malaysia?
There are a lot of derivative technologies, as I've said. For example, a simple example would be programming. Okay, let's say that actually we have a satellite mission, not a very expensive one, a low cost mission, and we want to do maybe a technology development or the technology demonstration for navigation system, for example. So therefore a lot of works will be done, right? Especially maybe by using GPS, codings will be done, computer codings, and all these actually solutions, practically we can implement that in terrestrial mode. That means we develop something for satellite. It's the same actually architecture, or the similar architecture that can be actually derived or rather deduced towards to other applications. For example, maybe for automobile applications. So a navigation system which been probably demonstrated in a satellite can very well actually be extended to applications like that. Let alone automobile, maybe for marine applications, for small boats, for example. So there are a lot of actually satellite technologies being finally deduced for common applications. That is actually possible. So, but the idea is that always we should start already having that idea of applying it to terrestrial applications before even you start the mission. It is not to say you after you design you think how to apply, but both you should think together. Then I'm very sure in terms of a return of investment you can get it for sure. Even if you don't get it through the space mission, but you should be actually able to spin off a lot of other applications, terrestrial applications. And I think that is the way forward. In fact, a lot of countries are actually doing that. For example, people have developed sensors to measure oxygen levels. How much of amount that oxygen being inhaled, for example, by the astronauts. So they have developed a particular sensors for the use of astronauts, right? Now that sensors actually can be also used in a terrestrial mode. For example, what is the intake a normal sportsman would have, and maybe for medical uses also. So there are many applications it can be found when you have already the device. So but it takes a bit of time basically because the space is not so straightforward. Qualification, and then testings, and all these are strict and needs money. As simple as that.
Okay, thank you, Doctor. We move on to the second question. So the second question is, there are many uses of satellites such as telecommunication, like May said one just now, remote sensing, security, and etc. So what kind of mission or missions are suitable for Malaysia development?
Telecommunication, remote sensing. Right.
Why is that?
Telecommunication, yes, of course we have a lot of mobile services. It's a must.
Yeah.
In fact, we already have it. But remote sensing is another application that we must have it. I told you just now, we have a huge amount of waters areas. So in order to do effective monitoring, and you have seen a lot of problems on the other side, East Malaysia. You look at, in Sabah, a lot of intruders. All this can be actually avoided, or rather can be mitigated by continuous surveillance. And a better way basically to do that is via satellites basically. Not only that, but I think you can have flood controls, flood alarm systems. You can also have landslide alarm systems. All that can be actually developed by just having a remote sensing satellite for the country. We are supposed to have it, but Razat didn't really actually materialize. So we are behind about 10 years actually. So that is something that government need to really think how this can be capitalized. It's just like, as I've said, having a satellite. You see, you have combat aircrafts, right? We have Sukhoi, but it doesn't mean that actually we are going for war. We have also submarine, but it doesn't mean that actually we are going for war. So likewise, we can have remote sensing satellites basically to help us. It's just like that. So good when we don't go for war, because we are a peaceful country. But it doesn't mean that actually if we don't go for war, we don't have all these military assets. So it's like that. So when people think that it is something that the country should have as a country, then I think remote sensing satellite is something that we need to have very urgently.
Thank you, Doctor.
Don't forget, we can also sell the images to some other countries.
Can you elaborate more about selling images?
Yeah, because you are flying over certain countries. For example, maybe in Southeast Asia, you can fly over maybe countries like maybe Myanmar or maybe Vietnam, but Vietnam they have their own. But other countries, Indonesia for example, they might be interested in the images. Right? So all these also there's some commercial values that we can have. So it depends which are the areas that we want to map. That's very important.
Thank you, Doctor, for a very nice opinion. So can I ask for the third question?
Sure. How many questions do you have, Olin?
We have 8
Okay.
total, but now left 2. So the third question is, when we launch satellite into orbit, I think you have answered this, but I just asked, what kind of data we can have from the space, and who will benefit from the data provided from the space?
The data, the actual data that you want to have is practically depend on the mission. Before you launch a satellite, you should make sure the mission is very clear. What mission you want to have? As I've said just now, 2 important missions in the country, or rather that must have telecommunication mission that we already have. Second is actually the remote sensing mission. So based on that, what you will have basically telecommunication data, all those telemetries you will have. For remote sensing data, you will have all those images that you need to process here. At the moment, of course, we don't own the satellite. Even if you look at it, UPM, we have a very good collaboration with the Germans. Okay, and we do download actually all these data, especially the images, through one of their satellites, through our ground station here. So, but it'll be good basically when we have our own satellite instead of other people's satellite. But then this is also is great because we don't. It's a collaboration, and we get an access of the images of Malaysia through a real-time images that we have, and it is important to have. So I think as a university, or rather as a university, when we be able to actually do that ourselves, I think the country can do better, or rather can do more than us, right?
Yeah.
So we are not the country, you know. We are just an university, right? So with a very limited budget, well, almost not much, we can actually do things that, you know, adds value to what we have. So I believe that the country can do even better than us with that fundings, formal fundings they have, and maybe, you know, the directions, and that's, I think, something that well, we can always talk about it, but hopefully it will happen one fine day. You know?
Thank you, Doctor. So we move on for the last question. From your point of view, we know that Malaysia is still a developing country, right? So what kind of challenges we are facing as a nation in developing satellite technology?
Simple. Fundings and manpower.
Why manpower? We have a lot of graduates from universities, right?
Well, when you don't have fundings, or rather enough fundings, you can't take on national projects, satellite projects, for example. When you have satellite projects, you need people, right? Then you create what? You create job opportunities for graduates or even scientists. People start working. When people start working, practically there is always a development already. So these two, why actually you don't have enough of manpower is because we don't have enough of projects, or we don't have any formal projects. When you have many formal projects, or other space projects that we have, government has. Can you imagine a lot of actually graduates will be able to work, right?
Yeah.
So then you develop the manpower, you develop the talent. So when you don't have, how you want to develop? It's not easy. So it's always back to the country's direction, the country's willingness to invest in space. Investment means you invest projects, any space projects, maybe 3 or 4 years projects. Then when there is enough of fundings, then you need people to do the work. Then you hire maybe first fresh graduates, or you can also hire some other scientists basically to work on the project. And then people are exposed to technology, people start developing things. First phase is done, then maybe you come up with another project, people have experience, people start actually doing better, and finally you grow higher and higher in the value chain. But if you don't start anywhere, why should you? Why should you actually work? Well, you may ask, what about Miasat? Miasat don't develop satellite. Miasat is end user. They sell basically the services. They buy the satellite from outside, and then they sell services. Just like Malaysian Airlines or even Air Asia, they don't manufacture aircraft. They buy aircraft and they sell services. So Miasat is the same. What we need to actually develop some, or rather start developing the device, developing the satellite itself. If it's not a big satellite, it doesn't matter. Even a small satellite is good enough for us to do the whatever I've mentioned before. For example, the remote sensing mission. You need that. I'm very sure when you have about 2 to 3 missions, like say every 5 years you have one, that means another about 15 years, assume we have 3 satellite missions and government's satellite, for example. I'm very sure in the 15th year, after a decade of all these projects, we will be great because of the exposure, and most importantly, you must take in people who's competent.
So Can you elaborate more about people who is competent?
People who is good, people who is competent, not anybody. Because, as I've said, rocket technology is different, right? Space technology is different. It's very, very complex. So you need very, very good people to work. You can't take anybody. But in Malaysia, we have good people. So you take them, you don't need 1,000. You need a handful to start with. So you take good people, you work with good people, I'm very sure you can do it. That's how actually people start, developing things. So it is it's very, very important to understand that. And but okay, it's fine. Whatever said and done in UPM, we will actually keep on working on it, especially to probably produce good, talented graduates, especially in postgraduate levels, masters or PhDs, experts in the field, and that is what I think is important, to keep on doing that. And when you have enough of people, I think, and then what is important is that few projects from the government, then it's fine. These people can participate.
Okay, I guess that's all our question for today's interview. Thank you, Doctor.
Thank you very much.
For